Hi folks, we're continuing on with the Unit 1 Day 8. This is video number 2. Now, at the end of the last video, I said that you guys could draw out vector OA and OB from that addition problem. And it's pretty straightforward. Hopefully you guys can see we had vector OA, which was 6, 1, and OB, which was negative 7, 4. And when we add those together, we get negative 1, 5. So you can kind of see a visual here as well, and I'll add this into the notes, that if we go 6 in the X and 1 in the Y, and then negative 7 in the X and 4 in the Y, we get to this negative 1, 5 sum of the two vectors there. So one of the other things we have to consider when we're talking about vectors in R2 or R3 is that we may not always have vectors that are kind of predetermined as starting at the origin. So if we have vectors that go between 2 points, and the formulas are here, but I really want you to kind of think about this conceptually. So if we have a vector that goes between 2 different points, and I'm just going to graph the kind of 2 general points on here. So I will put a kind of arbitrary point A and point B. Let's say there's A, which is x1, y1, and B, I'll just put one over here, which is x2, y2. So we want to figure out vector AB in terms of where this would be if it was reoriented to the origin. So what we really want is to get an A and a B value that reflect where this vector would be if you took it and kind of moved it back to start at the origin. And we know that we want to know the A times I hat. We want to know how much that A is, how much it goes in the X direction, and a B times our J hat unit vector, how much that vector goes in the Y direction. And hopefully this should be kind of dinging some memories from grade 9, because this really looks like the rise and the run, and that's all it is. So if we want vector AB, that would be given as the A value going across would be x2 minus x1. It's like the run in the slope formula. And the B measurement going vertically in the Y direction is like the rise measurement in the slope formula. So it's y2 minus y1. So essentially, if we get 2 points where a vector is going between 2 other points, not starting at the origin, we can find the equivalent vector reoriented to the origin by basically run and rise, x2 minus x1 and y2 minus y1. The other thing we want to be able to do is to calculate a magnitude of the vector, of any vector. And that, of course, is going to be calculated based on Pythagorean theorem. So the magnitude of vector AB is the square root of these two sides squared. So x2 minus x1 squared plus y2 minus y1 squared. So that's basically really the same as the distance formula that you guys did in geometry in grade 10. And we get the components of the vector based on our pieces of the slope formula, the rise and the run. So it kind of comes from the same idea there. So those two are really important formulas to know. We can also extend that to 3 dimensions. So if we're looking at a vector in R3, the vector AB is going to be the distance in the difference in the X values, the difference in the Y values, and we're going to extend that really the same to be Z2 minus Z1, just how far it travels in the Z direction. Very similarly, there is a formula for the magnitude, and this kind of comes from a a visualization, I guess, of the idea of this rectangular prism to get to a point. So the magnitude formula really looks like an extension of Pythagorean theorem, but I'd like to show you kind of why and how that works. So if we have a rectangular prism, and I'm just going to label these as X, Y, and Z. Okay, we know that the rectangular prism showing any point in 3 dimensions starts at the origin and goes to the opposite diagonal point. So I'll kind of show this as vector AB. And these X, Y, and Z's are actually like my delta X, delta Y, and delta Z. So the first thing I'm going to do, and this is just repeated Pythagorean theorem, I'm going to look at this base. So kind of the rectangular bottom of this box, and I'm going to find a measurement D there. And I think that we're all okay with saying that based on this right angle triangle, D squared is X squared plus Y squared. So this is kind of like 3D trig that you would have seen in your grade 11 math. It's a little bit harder to show in a 2-dimensional surface, but then we can make another right angle triangle here using this D that goes diagonally across the base, the Z that goes up and down, and this vector AB. So I'm going to make another triangle there that says D squared plus Z squared equals the magnitude of AB squared. But we knew that D squared was X squared plus Y squared. So I'm going to kind of combine those two formulas together. And then we have the magnitude of AB squared is D squared, which is X squared plus Y squared, plus Z squared. So I've simplified it a little bit and not written like x2 minus x1 and just had an x value there. But if we think of that as like the distance in the x direction that this vector goes, hopefully you guys can see kind of where this comes from. It's just a repeated Pythagorean theorem. If you do it once kind of on one surface and then once up through the middle to get that diagonal. So again, really important formulas there. You will need to memorize those. So if we wanted to find vector AB, remember that we're just going to take x2 minus x1. So it's 5 minus -1. And obviously you're not going to have to keep showing this. I'm just kind of showing the process. And then 2 minus 1. How far does it go in the x direction? Going from -1 to 5 is a change of 6. And going from 1 to 2 is a change of 1. Now, one difference with this compared to what you may think of like rise and run, the order here really matters. We're going from point A to point B. So if you switched around the subtraction and did -1 minus 5, then you're getting vector BA, not vector AB. So that really does matter. Then the magnitude of AB, it's the square root of 5 plus 1 squared plus 2 minus 1 squared. So that ends up as root 37. We're going to leave all of our magnitudes as exact values unless it's in a word problem where it makes sense to round to 2 decimal places. Missing a page.